Good morning. Today we are going to be taking notes on comparing ratios. This is on page 61 and 62 of your interactive notebook. You want to write down the topic, comparing ratios. The essential question for today is, how do I know if two ratios are equivalent? This is a continuation of our notes that we did last week on what are ratios. Remember, a ratio is a fraction or a comparison of two numbers. We're showing the relationship between two numbers or two items or two groupings. We can do this in using a fraction. We can use a colon, or we can use the word two. We also want to remember that there's three different types of ratios. There are ratios that compare a part of something to another part of something. There's ratios that compare a part of something to a whole group of something. And there's ratios that compare a whole group of something to a part of something. We also want to remember that we compare ratios and we decide if one ratio is greater or less than another one. So that's what we're going to focus on today, is how to do that comparison. By the time you're done today, you should be able to answer that question: how do I know if two ratios are equivalent? What does the word equivalent mean? Miguel?
Equivalent means what is it equal to?
What is it equal to? A little bit more clarification. Elizabeth? Equivalent means the same. So you were right, but I want that word. Just think of equivalent is a synonym of the same. Okay? All right, so our standard for today is 6 ratios and proportions, number 1. Once again, you should be able, by the time we're done with this lesson, to compare ratios. So this dude right here is, I guess, Peter Parker, and it's from an old school superhero cartoon, Superman, and or Spider-Man. I said Superman. Forgive me, it's Spider-Man. How embarrassing. Just like Peter Parker and Spider-Man, have you ever seen in superhero cartoons or whatnot where the superhero is like one guy in his day-to-day life and then like he transforms into like the superhero? They're the same person, right? But one's like a super version of the same one. Those two people would be equivalent. They're the same, but they're just in different forms. So that's kind of the same thing that we're trying to look for. We're trying to see if two ratios are like that. The same inside, but like different forms on the outside. So just like Peter Parker and Spider-Man, or like Clark Kent and Superman, are the same person, 1/4 and 2/8 are the same. Now, ratios, one of the ways that we write them is we write them as fractions, right, guys? So when you look at the fractions 1/4 and 2/8, are they equivalent? Are they the same? Can you simplify 2/8 to 1/4? You can, right? So it's the same thing. When you're thinking of a ratio, just think of an equivalent fraction. Is it equivalent? Is it the same? Could you simplify to get one to match the other? So remember that equivalent ratios, I'm going to scroll this down, are equivalent fractions. And when we're thinking of equivalent fractions, that's totally not scary because you guys have been doing that for quite a while. So just think of it from that perspective and you'll be okay. So to find an equivalent ratio, here are our steps. The first thing you're going to do is you are going to multiply. And before we do that, I want us to circle that term, equivalent, and I want us to circle ratio. Those are big words. Remember, equivalent is the same. Okay, so the first thing we're going to do is we are going to multiply. And I'm going to give us an example of this. If I were to have 2/3, and if I wanted to see, is it equivalent or the same to 4/6, I would figure out, can I multiply or do a multiplication problem to get 2 to 4? What could I do? Is there a student who, other than Elizabeth? What do I do to 2 to get to 4? Looking at those two fractions, what can I do? Isaac.
Multiply it by 2.
Right, I would multiply it by 2. So whatever you do to this top one, the numerator, you're going to also do to the bottom. Does it work out? If I multiply 3 times 2, do I get 6?
Oh, yes.
So are they equivalent? They are indeed equivalent. So 2/3 would be equivalent to 4/6. So you're looking at the relationship between the two numbers. Can you multiply the numerator by the same number as the denominator to get it to work? You could also do this by, if I were to give you a ratio and I were to say, okay, I want you to find an equivalent ratio to that one, you could do the same thing. All you would have to do is find a number that you multiply the numerator and the denominator by, and that would give you an equivalent one. So, Miguel, can you help me with this one? If I take 1/4 and I'm trying to find an equivalent ratio to match it, what number could you multiply the numerator and the denominator by to make an equivalent one? It could be anything.
You can multiply it by 2.
Multiply by 2? Okay. So if I multiply 1 by 2, what am I going to get? 2/8. Okay, so you jumped right ahead of me. So I multiplied 1 by 2, I got 2. I multiplied 4 by 2, I got 8. And so 2/8 would be equivalent to 1/4. Well done. Another thing that we can do is we can divide. So first thing we multiply, or we can divide. So let's say we get a bigger ratio, like let's do 12/20. And I want to find an equivalent ratio to this by dividing. What is a number that we can divide both the top and bottom in order to get something equivalent? What could I divide 12 by and 20 to get an equivalent ratio? Jacqueline? So you said divide 12 by 2 and divide 20 by 2. So if I divide 12 by 2, what am I going to get, Jacqueline? 6. Awesome. And if I divide 20 by 2, what am I going to get? 10. So would 6/10 be equivalent to 12/20, class?
Yes.
Yes. Could I still do another one? What could I do, Elizabeth? Okay, and what would I get? 3/5, because you took both. You divided 6/10 by 2 on the numerator and the denominator, and you got into 3/5. Those are all three equivalent. Not one is the correct answer. They all work, because all I'm asking you is to find ones that are equivalent or the same. All right, so now we're going to go over to 61 on our practice page. Okay? On page 61, let's read our text here. I'd like us to read it all together, please. Here we go. At our school, there are 252 students in the 6th grade and 9 6th grade teachers. Write the ratio of students to teachers in simplest form. So we're going to circle the number 252. We're going to underline students because 252 represents the amount of students. We're going to do 9 6th grade teachers. And we're going to box our question, write the ratio of students to teachers in simplest form. Okay, so we have 252 students, and we're doing students to how many teachers? Class? 9 teachers. Okay, I want you guys to now figure out how to simplify that. If you were to have 252 over 9, what would be an equivalent fraction using probably the division system? And then below, you also have 4 fractions. I want you to, using either multiplication or division, find equivalent fractions for each of them or equivalent ratios. All right? If you have any questions, please go back and review the notes. Also, you can email me or you can ask me for any questions that you might have. Thank you so much and have a great day.